Water distribution systems. We depend on them for our supply of water, yet to a large extent they are invisible. We just turn on the tap and the water comes out. Hi, I'm Dave Bender. In rural areas, a distribution system can be as simple as the pipe that carries water the 50 feet from the well to the house. But in our cities, a water distribution system can be an amazingly complex assemblage of pipes, valves, reservoirs, fire hydrants, service lines, meters, pumping stations, and other components that require ongoing monitoring and maintenance. Distribution systems must deliver water to homes, businesses, and industries for drinking, washing, and other such uses as firefighting. The quantity of water must be enough to meet the demands for usage up to peak demands and should provide adequate water pressure throughout the system. All of this must be done without compromising the quality and safety of the water itself. No easy task. Today we are going to take a look at some of the basic tasks and skills needed for maintaining, repairing, and protecting water distribution systems. We'll show you a procedure for flushing a system, how to locate buried pipes and leaks, and how to make some basic repairs. In the last segment, we will look at some cross-connection control devices and see why they are important. Let's start with system valves. These make it possible for one part of a distribution system to be isolated from the rest and allow for maintenance and repair of a system. Here's Mike Cherniak and Scott Baer talking about some of the main types of valves used in a distribution system.
Scott, you're superintendent of Carmichael Water District. I see you've got a bench set up for some valves you want to talk about today.
Sure.
Why don't we just start with your basic on-off types?
Okay. This one right here is just a PVC valve, and it's just a positive shut-off. Turn one way, shut off, direction of flow. This is a solvent and glue style type thread here. Yeah. This is your typical gate valve, which is found at most homes, and some of the older districts probably have these in the ground also. It's just a disc style. Just shut it down and it'll turn that water off. Sometimes you get a little bit of debris down in here, and what you want to do is just turn it down, pull it back up, exercise it a little bit. It'll get some of that debris broke off in there and allow you to get a positive shut off on it. This one here is just another style of the PVC valve over here, and it's the same thing. Quarter turn, it shuts off, and then inflow right here. This has a female iron pipe thread on both sides. Allows you to adapt to whatever material you are working with.
Okay. I guess it's important to note here on all these that exercising is probably a very good thing.
Exercising is a very important thing. They're going to get buildup inside of these. I think this 2-inch valve over here, Mike, that's sitting in front of you is a perfect example. You can see here we've got a lot of debris that is built up in this valve. And I think the reason why we took this out of the system is we couldn't get it to shut off all the way. We exercised it down and up and down. Could not get that debris to come off. We were still getting flow back in to the system where we were working on, so we just decided do a shutdown. Let's take this valve out and get it replaced.
Okay. That's good.
We come over here. Yeah, this is more of a probably, I would say, district owned, maybe stuff that would be at a point of connection or at the water main itself. We'll start with the water main. This is just your typical 1-inch corporation stop, and this is the operating valve right here. Straight up and down would be your inflow. This is actually an insulated 1-inch, and you can see it here. We have a plastic disc here, and then a rubber O-ring here that would actually seal the unit from leaking. You use a lot of this. Keep the electrolysis off of the ductile iron pipe, especially if you're running a copper service into something like this. This insulates it, saves that ductile iron pipe. Get a lot of years out of it.
Okay.
Then we come into here. This is another style corporation stop here. Of course, the same threads on this end. This is more of a compression style fitting, which I believe this is a 110 compression.
All right.
Put your copper in here. Screw it back down, seals it up. Okay. Again, your flow is going to be the same way here with the valve.
So this one is not insulated?
This is a non-insulated. I use this a lot on a PVC, C900, those style mains, or just non-metallic, basically,
Okay.
is where you want to use this in.
Now, we get this set up, and I guess these are all components. Why don't we pull the
Sure.
this meter setup over here for you? You can kind of show us.
Yeah, this is your typical 1-inch meter installation. What you have is you have your inflow water coming in through here into a ball valve with a locking wing.
Okay.
Right here. And it goes through this ball valve into the meter itself, and then it is registered. The information is kept in the register here, and then along comes the meter reader. He touches the wand here. It takes that information from the register up into this and then into his handheld wand, and then in turn is downloaded into the computer and billed on a bi-monthly is what we do here at the district.
Any weak link here? These wires get
Yeah,
bent?
well, yeah, you know, you're out there in the field. If you have any type of lid, concrete, steel lid, you're going to have that problem. Maybe that wire is going to get sheared off. Or, you know, these can handle a lot of weight, these touch pads. But then again, you get a lot of abuse, maybe garbage trucks, big rigs, something like that. They're going to break these down. Simple repair there. You can get the register separate from the meter body itself. Replace this. It's just a simple screw-off type here. Take the register out, put the new register in, away you go. You haven't interrupted their service at all. Okay. So it's a good little setup.
The meters themselves, do they go bad? And if so, why?
Over time, yeah. Of course, you're going to have some debris coming in through your system, whether it be sand, maybe you have an old steel main that's got debris in it. Sometimes you're going to get it, they're actually going to plug up the nutating disc inside, or they're going to clog up the screens. A typical fix there is just turn it over, take the bottom cover out, and all the parts are replaceable.
Okay.
So we've got the water coming in through here. This is a double check valve assembly here that our district uses. It allows the water to only go one way. Mm-hmm. Customers' water will not infiltrate our system when we have a shutdown. Okay. So then we come out of here, and this is your typical 1-inch meter installation at point of connection.
Can we take these out pretty easily?
Yes, you can. It's just a multi-purpose end right here, and just unscrew it on both ends. Take that meter out. Put another one in, new gaskets, away you go.
Even I can do it.
As long as you shut it off.
Okay. Remember that important point. Okay, looks like a pretty typical setup.
Yeah. And then
get on to a few of the bigger valves here. What do we have?
This is your typical resilient wedge gate valve here, used in probably most systems, probably throughout the United States. This is a flanged face valve here. It is a right hand. That's the only thing we use here at the district. It's right-handed. And it's the same principle as a smaller gate valve that we looked at earlier. It's just a simple turn. The valve goes down, the disc, and then back up. And it's a fairly foolproof valve that's been in systems a long time. It's very reliable.
These are important in your system, isolating. You need to know where these are, for one.
It's always good to know where they're at. You always run into that 3 o'clock midnight shutdown, whatever it may be, and a good mapping system pays for itself. That's for sure. Good
Second,
valve.
you like to have these exercised.
Yeah, part of that exercising, which every district should probably take a look at some point in time, is a valve exercising program, which also allows you to locate these valves. So if you know where they are, exercise them, run them up and down. It breaks that debris off of the disc inside and allows you to get a solid shutdown.
Last question. If it's been sitting there and haven't exercised it too long, is it possible, can I actually, when I go to need to open that or isolate that, torque that thing right?
You're going to run into problems. Some of the older valves probably put in, 30 years ago. Yeah, you're going to have that debris in here, and it's not going to allow you that free is what I'm doing here, is just being able to turn this with 3 fingers and letting it go up and down. What's going to happen there? Either you'll shear it off down in here on the brass stem itself, or you're going to break the nut off the head, which is probably your most vulnerable point up here, is when these valves get old and brittle.
Is packing in here? I can get to that?
Yes, there is.
Do some
You got your 2 bolts here, right here. This comes out of here. take your nut off. You got some packing inside. A lot of the older valves, you'll probably have to do this in time, is just replace the packing.
Okay.
And then also you can take the whole bonnet off itself once your system is isolated to do the repair in here if that brass stem does break.
Okay.
So then we go on.
What do we have here?
Well, this is a butterfly valve. This is a 3-inch butterfly valve. Of course, flanged on both sides. Operating nut is off to the side. It's based on a worm drive theory here, and it just takes it down.
Okay.
And if you can see inside, and we're closing the valve there. And it's the same thing when you come up. The one thing with these is when they're off, you don't want to over tighten them. I mean, that has happened more times than anything, is you get into the butterfly valve, since it is a worm style gear, you can break the gears and the shear pins in here, which is a lot easier than replacing them on the gate valve itself. But when it's shut down, that's it. You don't want to over tighten these.
Now we use butterfly to adjust flow too, throttle flow up and down,
you
rather
can
than
throttle
just
flow.
isolate.
Yeah, you can throttle flow most of the time out of a pumping station, water treatment plant, somewhat of that nature. It is a good valve, especially when you get up into your larger diameter transmission mains. You get up into your 24 inches, your 48s and above, you're probably going to see a butterfly valve in there.
And we can do this along the pipe rather than having a...
Exactly, exactly. Yeah, when you look at finish grade and your flow line of your pipe, that's something you've got to take into consideration when you install them. Of course, if you have a 48-inch valve, you're going to be 4 foot high, and then plus your stem height, you know, so.
One more question. These come pre-packed with grease.
Yes, they do.
Pretty good to go.
Yeah. There is no water inside of this unit, so you can work on this unit here with the system still on.
Oh, great.
So there's no worry about taking this cover off and getting all wet. Of course, there are seals in here that maybe could go bad and whatnot, but theoretically, if the stem breaks here, you can replace the pins and the gears inside without taking the whole unit out of system.
Okay, we like that. All right, how about this big boy?
Yeah, this is a 4-inch swing check. Typical, probably a lot of pumping stations, water treatment plants, reservoirs, somewhat similar. And what you have in here is just a swing check. It just comes up, allows water to flow one way and one way only. You do have problems with these somewhere down the line, especially if your well site's a sand pumper. If you're getting a lot of sand in there, that rubber is actually going to pit on here, and it's going to allow that water to go back into your system when you have a shutdown on the opposite side.
Okay.
Simple to replace. Of course, isolate on both sides. Go ahead, take your nuts off, and then your 2 bolts here, and then you can go ahead and repair your system then.
I know if it's quiet, you could either put your ear in the pipe, use a stethoscope, just to hear the flow.
Yeah, so some type of hearing. You can actually hear that water screeching back through in there, yeah. And it's a pretty good system.
And if we take the nuts and bolts off here, we can replace
Yeah, you can replace everything from taking this lid off of this check valve right here, and of course, these 2 large bolts on both sides is actually where your swing is actuated at. This is just a swing valve. You do have spring-loaded check valves also, which of course, spring, it can go bad.
Bad too,
but you can repair everything right here from the top.
Scott, any final advice for our viewers on valves?
Yeah, I'd like to touch on 3 different items here. You want a good mapping program. You want to know where those valves are located at. The last thing you could do is what you want to happen is getting in someone's backyard, not knowing where your valves are. Secondly, an exercising program. You're going to want to exercise these valves at least annually every year. Thirdly is inventory. You're going to want a good parts inventory, probably of the most common parts you have in your system.
Okay, little planning goes a long way.
Yes, it does.
I do all that. I won't get called out at 3 in the morning?
I can't guarantee that.
All right. Hey, lots of good information. Thanks very much.
Okay, you're welcome.
Sediment and mineral scale can accumulate in the distribution system. When there's too much, valves may not work properly and customers complain about low water pressure and flow. Flushing is a way of keeping the mains clean for consumers and ready for a fire emergency. Let's go on location with Mike and Brad Stone to see how it's done.
Brad, we about ready?
Yes, sir.
Okay, we're going to flush a hydrant today. It's a relatively straightforward procedure, but it's so important in the proper operation, maintenance, of distribution systems. Why do you guys flush hydrants?
We flush mainly for taste and odor, sedimentation, and some iron manganese problems.
Okay, and what kind of program does Carmichael Water District have?
We have a dead-end main project, a customer complaint generated type flushing,
Okay.
and then there's the routine flushing, which is a localized flushing.
Okay, so we're flushing, we get dirt out of the system. It also gives us a chance to exercise the hydrant, so if a fire department ever has to use those, they know that it's actually going to open.
Hydrant's good, yeah.
All right, before we get started, I see we have some components here. Why don't you kind of walk us through what we have?
This is a diffuser. It hooks onto the front of the hydrant, diffuses the water or reduces the energy of the water coming from the hydrant.
Okay.
Inside of the diffuser here, there's a capsule for thiosulfate tablets. And what these do is they dechlor the water so that when it drains back to the American River, that it's not killing, the chlorine's not killing the aquatic life.
Okay, and I think there's good fishing in that river, right?
Yes, sir.
All right, so the tablets go in. We have a hose. Are we going to be using that today?
No, well, we have a good direct shot right into the gutter here. So this would be more for directing your flow in a certain direction, so to speak,
Okay.
or a smaller hydrant.
Finally, I notice we have a cup here.
Yes.
What do we use this for?
That's something I use just for kind of sampling the water as it's flushing. You know, I can kind of see if there's anything floating around in there. I can look and see if I'm done, is it clean, or if I need to continue the flush.
And typically, how long does your flushing procedure take?
Usually about 30 minutes or so.
Okay. Well, we'll move some of this out, let you get started.
Okay. Good.
Is there, I notice we're in a quiet kind of place, not a lot of traffic. Is there any other concerns you have other than traffic safety?
One thing is all the water and everything always brings the neighborhood kids or just people in general. So you have to kind of watch out for them, you know, make sure that everything's safe for them.
All right.
The other thing would be property damage. I mean, you don't want the water to drain into someone's yard or, you know, blow up into somebody's yard, so to speak, and cause
Okay.
damage.
Well, I'll get out of the way and let you start the flushing here. Okay, that was about 25 minutes.
Yeah,
How'd it look?
it looked good.
All right, take a look.
Clean. Sure.
Let's see what you. Oh yeah, okay. I noticed it was only it was dirty at the beginning, but very little.
Yeah,
So
yeah.
it's probably
Yeah, we
evident
train.
of a good flushing program.
Yeah.
What do we have to do here to close up, right? Anything?
Basically, just take our diffuser off, make sure the cap is secure, everything looks good, you know,
Okay.
the way we found it, and
Sounds
be
good.
on our way.
You keeping notes of this, or is there?
Yeah, actually, I'll make a notation that the date and when I was here, so that I'm covered. I know where I've been.
Okay, sounds great. Well, thanks very much for that.
You're welcome.
All right.
Maintaining accurate maps of distribution systems and their underground components is really important, but maps aren't always perfect. If you have incorrect or missing information, how do you locate buried pipes? Here's Mike with Chris Mayer to show you how.
Chris, I got the grounding rod and the paint. You got the heavy stuff. You're utilities coordinator here for San Juan Water District?
Yeah.
Okay, and a big part of your job is to do leak detection, locates?
Locates, customer service, and the cross-connection control program.
Oh, okay, all that. Okay, we're going to do a locate now.
Yeah.
And why do we do locates?
Well, the reason why we do locates is we want to locate our pipes and our laterals for our contractors and our own guys. And the reason why we do that is because we don't want them to hit anything while they're digging. And so what eventually happens out here is you'll see an above-ground map of all the utilities, and I mark the water.
Okay, so we make a map on the surface for folks that are going to come out here. Do they call you directly? Is there a call before you dig program?
No, yeah, they do call the USA, and that stands for Underground Service Alert, and that which we're a member of. And of course, when they call that, they notify all the other utilities in the area, and the utilities, cable TV, sewer, us, gas, electric, all come out and mark their own stuff. And
pretty straightforward
Pretty
program?
straightforward, yeah.
Okay, and when they don't call, things get broken.
Things get broken,
Okay.
that's right.
Show us how you're going to do this.
Okay, there's 3 different components here. You have the transmitter,
Okay.
and you have the receiver, and you also use the ground rod here.
All right.
I'm gonna go ahead and put that right here. And what I do, if you hold that for me,
Hold
please.
that.
I come over here to the service box. This is a typical meter install. I pull the lid, and what I'm going to do is I'm going to hook directly to this copper wire. And that copper wire is ran on the same trench line as the service lateral and also the main line.
Okay.
Because the pipe here is polyethylene, and also the pipe out in the street is PVC, and it's non-metallic and it doesn't carry a signal.
So you put that tracing wire in all the pipe installations.
Yep.
Okay.
Okay, so I'm going to directly hook up.
Now, like
There.
a positive and a negative, just like
Yep,
battery cables.
that's right.
Okay.
And go ahead
Ground
and
it.
Ground it. Go ahead and turn it on. And what it's showing now is my battery strength.
And this is really a signal generator.
Right, right.
Okay.
I gotta wait a few, then it's gonna give me my signal strength. And here we have it. I have 3 solid bars, which actually represent my signal strength. The more of those I have, the stronger the signal. And this flashing bar here is my resistance. The further that is over to the left, the less resistance I have. But that's adequate for this locate.
Okay, good.
And then I go ahead from there, I grab the receiver and turn that on. And if you notice, there's a broken arrow with a broken tone
Yeah.
and a solid arrow with a solid tone. And it's when I center myself over the target that both tones drop out. And then when I do that, I can go ahead and depress the depth button. And that tells me that wire is 1 foot 4 inches deep at that point.
Okay, and right under this line.
Right under it. What I do now is I go ahead and mark that.
Okay, and you would do that.
I do that,
And-
and I take a step back. And here on sidewalks, I just put dots.
Just
Out on the
dots.
road, I put arrows.
Okay, and this this particular paint,
It's a water-based inverted tip marker. You can get this at your hardware store.
so it'll just wear away.
It'll eventually wear away. Some people use chalk. Chalk doesn't last long enough. I prefer the water-based stuff
Okay.
myself.
Sounds good.
You go ahead and hold
So
that there.
we're gonna dot it down.
Right. I'm gonna take a few steps back. Again, the signal, the sound dropped out, so I'm centered over the target. Again, we'll go ahead and take another step back. Go ahead and get a depth on that. 1.5 feet deep. That's what the wire is.
Okay.
And we know the main line's out here. I'm pretty much standing on top of the main line, but I want to find out exactly where that lateral ties into the main. And it will be about right here. Okay, now I've got the lateral marked. I need to step off and find out where the main line is.
Yeah.
And so I'll take a few steps this way. Okay, now I'm on top of the main. And where the two meet, that's where the lateral takes off.
Okay.
Okay?
Sounds
That's pretty much
good.
it. It's real simple.
Straightforward. Couple questions.
Sure.
Do you ever have any glitches in this? I mean, is there some things you got to be aware of?
Oh yeah, There's a lot of things. The more you use it, the more you know over
Yeah.
time. Bare copper wire has a tendency to disperse its signal throughout the ground, and if there's another utility close, it has a possibility of charging that utility, and you of course take off marking cable or gas when you should be marking water. Another thing is bare copper wire is susceptible to minerals, and it can eat the wire up, and it doesn't carry continuity very well.
So you learn these things as you go. Well, most of
Absolutely.
the time, it does what you want it to do.
Most of the time, yeah, most of the
Okay.
time.
Now, when you leave this site, you go back and document this? Is there any paperwork to go with the procedure?
Yeah, each of those USA tickets that come into me, what I do is I put those on a spreadsheet, and I go ahead and log them in there for future reference, and just in case somebody hits it and hits one of our utilities and cries woof and says we never marked it. Yeah, well, yeah, we did. So that's what it's there for.
Okay, and finally for our viewers, basic cost of a kit like this?
The cost of this locator probably run you about $3,000 to $4,000.
Okay, and you get that back. That's got to pay back
Oh,
from
yeah.
time and labor saved.
Absolutely.
Repairs.
Absolutely.
Okay, I hate to say this, but I've learned a lot here, and in fact, it looks like even I can do this.
Yeah, I think you can.
Thanks, Chris.
You bet.
Pipes don't last forever, and we all know that at some point in time, we will probably experience a loss of water and/or pressure in a pipeline. Water lines spring leaks for lots of reasons, and you've got to find them to fix them. One way is to hire a contractor or invest in some specialized equipment. Here's Chris again to reveal some secrets about leak detection.
Well, Mike, we just did some pipe locating. Now we're going to do some leak detection.
Okay, my job's easier. I only have to carry the can this
Oh,
time.
yeah. I went ahead and already marked the main line so we can
Just
simplify
zero
things.
in here?
You bet.
Okay,
This is the leak detector that we use.
all right. A few
And
components here.
A
What
few
do we have?
components. Well, what we have here is the control box. This is the brains of the operation.
Okay,
And here we have the actual ground microphone itself.
okay.
If you notice here, we have a metal plunger.
Yeah,
This stays in contact with the asphalt. You have a rubber seal here, which keeps out some noise and also some moisture.
okay.
Okay, let me plug all this in
Plug
for
all
you.
that in.
Yep,
While you're doing that, let me just ask you.
sure.
You guys have a formal leak detection program, Chris?
Not a formal leak detection program. Those are usually reserved for some of the bigger companies. We do have a leak detection service that we provide our customers if
Okay.
there's a leak, and also do it for our guys, our crew.
So if you get a report of a leak, you react to that?
Yes,
Okay. Sounds good.
just a couple more plugs and we should be there.
And I'll ask you this, I know that we're using this unit out here on with the asphalt. If we had to do a detection on a lawn or some turf or something, you have a setup for that also?
Yeah, and I'll show you how that works after this.
Okay, great.
Okay, I think we're ready to roll.
Just simply put that on.
Mm-hmm.
Pull this out of the way.
Okay, Mike, when I go ahead and when I turn the unit on, it automatically presets itself to where the sensitivity and the volume are set at mid-range.
Okay.
And it has different frequencies or different channels of clarity. And I can go ahead and change those channels if I wanted to, and see whichever channel's best that I could hear the leak through.
So you get like a sensitivity and a volume?
Yeah,
Okay.
both those work together. And so what I'm going to do here is make a pass and see if I can hear the leak, and then we'll shorten our stride up and go from there.
Okay.
Okay. Don't hear anything there as yet.
Nice.
You want to go about every 5 feet
5
until you
feet or
hear
so?
something.
Okay.
Now I hear something. Now you want to shorten your stride up,
Okay.
but every 3 feet. Okay, now I'm a little bit louder. Now what we want to do is we want to take baby steps through the leak.
Okay.
What this particular device does for us, it will memorize your last 10 reads, and we'll display those on a bar graph. So as you approach the leak, it'll staircase up towards the leak, and as you go beyond the leak, it'll staircase down. And you would continue that way till you'd be finished.
Okay.
But again, as you get towards the leak, you need to baby step a bit.
So you want to try to get as close as you can to that leak. Is
That's
that
right.
right for your
That's right.
folks?
And you might want to make several passes to do that, so you can put the guys in a good location so they don't have to do a lot of digging.
Okay, and that's what my paint is for.
That's
You
what the
mark
paint's
it,
for.
X marks the spot?
That's right.
Okay.
And then after that X, I'd call in a USA, then call a crew out.
Okay. Gotta ask you, does it sound like a, or more like a?
That was you? Yeah, I heard both before. Yeah,
Okay.
I've heard both.
Chris, sounds like this is a little bit more of an art, or both an art and a science here.
Yeah, it's more finesse work than pipe locating.
pipe
You have to receive the training and practice.
So the more you do it, the better you get at
That's
it.
right.
Any particular problems you have when you're doing this? It doesn't make it that straightforward?
The size of the leak is one. If the real small leaks are tough to detect, and also the material the pipes are bedded in. We do have a subdivision that has a lot of river rock in there, and the leak can make an echo off those rocks, and it plays tricks with your mind, so you have to do some finesse work there. Most of the time you get them in the ballpark, but there are a few times when you get them somewhat close.
Okay. And final question here. For our viewers again, about how much does a unit like this cost?
I believe around $4,000.
Okay. And I think you can get a payback on that pretty
Oh,
quick.
yeah, oh yeah.
Okay. I'd like to see you, that little setup you have for the lawn. Can you do that?
Let's go. Now, Mike, you asked me earlier how we locate leaks in grassy areas.
Yeah.
This is the ProBrod setup.
Okay.
And it's a simple 2-piece ProBrod, T-handle. And this is the ground microphone portion. And it ties into the control box.
Just a little bit different microphone.
A little
that's
bit
all.
different microphone.
Okay.
Yeah. And what we do is we go ahead and first an accurate locate of the pipe.
Yeah.
And we'll go ahead and run that ProBrod, you know, where the pipe is. And sometimes when the ground gets a little bit tough, it's too hard, we can use a bigger ProBrod and run that down.
Kind of make a guide hole
And
there.
make a guide hole and go ahead and put that one in there.
Oh, nice.
And then we'll go ahead and chase a leak that way.
Same kind of thing, sensitivity,
Same
volume.
principle. Yep, you got to play with the sensitivity and volume.
Okay.
Look at the bar graph, make sure it's ramping up and ramping down as you get passing the leak. That stuff.
Same kind of sound.
Same kind of sound, yeah.
Okay,
Same kind of sound.
Chris, difference in asphalt and turf, if you have a choice, is there an easier one to work with?
I'd rather work with the road.
Okay.
I've had more success there.
Okay, great. Sounds pretty straightforward.
Yeah.
Thanks very much.
You bet.
So you found the pipe and the leak. Now for the repair. There are a number of ways a leak can be fixed. Let's start with couplings. Selecting the proper repair clamp for the job and following the correct procedure ensures you get it right the first time. You don't want to come back and do it again. Here's Mike with Chris Nelson to show us a selection of couplings and how to use them.
Hey, Chris.
Oh, Mike.
Hey, see you setting up a bench here with some equipment to repair.
Yes, we are. Yeah.
Why don't you show us what you have?
Okay, well, first thing I would like to show you is this is just a basic repair clamp. This is for a temporary repair to a water leak.
Okay.
It has a thin rubber that does not cover the full band itself. It would be used basically just as a temporary repair. You can go back
Okay.
the next day and actually make a more permanent one.
All right, just a big Band-Aid.
Basically, yes.
Okay.
This is the same idea, except for it has a rubber that will cover the whole pipe itself. And that would seal the pipe better, make it a more permanent repair.
Okay, and you'll show us that one later.
Yes, I will.
Okay.
Moving over here, we have larger bands. These are full circle repair bands. We use them for repairing the larger water mains. These will actually clamp down onto the pipe
Some
itself.
teeth here.
Exactly, these teeth
right.
interlock. And you have a rubber that covers the whole band itself, and it does overlap, so it will seal out any
Seal
leaks.
on. These are very reliable.
Yes, they are, as long as you tighten them up and make sure that you got it all the way down, because you don't want your partner to go back the next day and fix your mistake.
You will never hear the end of that one.
No, you won't.
Okay.
Same idea. This is a full circle repair clamp used on the larger mains, except for it has a 2-inch tap. Now this would be used for in case a valve blows off the water main during the middle of the night.
Okay.
You'll want a quick and easy way to get that repaired. This is what you'd use. You'd accommodate a 2-inch to a 1/2-inch valve using a bushing. So
Okay.
that is
I noticed you say in case the valve blows off in the middle of the night.
exactly
That's
that's
probably
when
a
it
good
usually
long
happens.
night. Okay. We've got some couplings here.
Yes, we do.
have?
Now, what I showed you earlier, we'd use to fix, a little hole in a pipe.
Yeah.
Those are clamps. But sometimes the pipes actually do break in half, and that's where a bolted flex would come in. It would join 2 pieces of pipe together. It's a mechanical coupling. But the nice thing about it is you can join PVC to a metal pipe.
Metal. There's compression fittings in there?
Yes, there is, and I'll show you how that works
Okay,
a little later.
great.
Along the same idea, we have a barrel flex, and that is compression fitting also. This is for copper tube size though. So this is for joining 2 pieces of copper together.
Okay.
Okay, and of course this looks almost identical except for larger. And this is also a barrel flex. You would use this on a PVC pipe, and this is iron pipe sized.
Okay.
Okay. Another way of coupling pipe together, PVC pipe, is by using a non-mechanical fitting. This is a slip-by-slip coupling, and you would
Okay.
glue 2 pieces of PVC together.
to PVC.
And I'll show you a little bit more about that later.
Okay, great. Good intro. I'm anxious to see how you use this stuff.
Okay.
Let's go do that.
All righty.
All right. Okay, Chris, what's going on?
Well, today I'm going to show you how to put a full circle repair clamp onto a water main.
Okay.
This is the full circle repair clamp I showed you earlier.
Yeah.
And today we're going to show you how to put that onto a piece of ductile iron pipe.
Okay, what happened to this?
Well, this pipe itself usually won't show a leak, but we're pretending that a contractor's coming to the district and put a hole right in the middle of it with his backhoe.
Okay.
So we need to stop that. And the first thing you need to do is to make sure that you have a clean surface to work with.
All right.
Okay? You'd scrape off that water main and make sure that you have a nice, smooth, even surface.
Okay.
Now that will allow you to go ahead and take a measurement of the pipe. You need to get that measurement of the outside diameter of it. Very important so you can match up and get the right size band.
Okay.
The way you would do that is you could either look it up on a chart, because most of these pipes have an outside diameter, that is standard. But if you don't know that, you'd use an outside diameter tape.
Yeah, I mean, go ahead. I'm looking at it. It looks like it's about a 4-inch pipe, but it's probably bigger around the outside, right?
Exactly, and that's what the outside diameter is. Now this tape tells you, inches on one side and the outside diameter on the other.
Okay, it's got a built-in calculation.
Basically, yes. So you'd wrap that around, so you get all the way around that pipe, and you bring it up to the line right here.
Okay,
now,
see that.
We can see this is 4 up here,
Right.
and 8.1 down below at the line. So
Okay.
that's 4.81.
4.81 inch outside diameter.
Outside diameter.
So now we can call in and try to find a clamp that fits that.
Exactly, or you can take a look in your stock, and we're lucky to have one right here that has the numbers written right
Yeah,
inside.
4.74 to 5.14 inches, so we're right in the middle there. That's a good one.
Exactly.
Okay,
Okay, so now we've scraped the pipe off.
clean.
We have found out what our outside diameter is. On this particular case, we're not going to have to disinfect the water main because we're not going to shut it down.
All right, it's under pressure.
Exactly, and that's where a repair clamp comes in real handy. You can do this all live, as long as your pump keeps up with the water.
Okay. Sure.
Exactly. So we come in below this and wrap the clamp underneath. Now you want to make sure you get this rubber,
Sealed in there?
the rubber flap underneath the teeth, and sealed up and around. Okay.
Okay.
You
got
pull the
your-
teeth together, and you would
the bolts.
set the bolts.
Okay, I see you're starting with that. You always start with the middle bolt.
Yeah, the middle bolt's the best to start with. That way you can tighten it from the middle to the outside. That way the rubber, you're pushing it from the middle to the out.
Okay,
Okay, and now we have gotten that one
got that.
started.
We'll
Go
take
ahead.
some tools here, and you want to tighten the rest of those down?
Yeah, we can go ahead and get that going.
Okay,
All right.
All
and
right.
now we have it
looks pretty tight.
tight. Exactly.
Anything else here to point out to the folks?
Well, one thing I do want to point out to you is on the back side of this band, there
Okay.
is an arrow, and that indicates the rotation of the band.
Okay,
When you're out in the field, you're going to need to move this band around to fit it on top of the leak. Now, there's only one way you can rotate this. You have to rotate in the direction of this arrow, or you might fish the rubber that's inside here
yeah, and
upon
crimp
itself.
up. That's not a good thing.
No, you won't get a tight seal.
Okay, looks pretty straightforward.
It is, unless it's raining outside and you're working in the mud.
We have those days. It looks like this is going to last a long time, Chris.
It should.
Now, Chris, oh, I see. We got a hole here.
Yeah, we got a pretty nasty hole right here in this this old galvanized pipe.
Okay, this pipe looks like it's ready to be replaced.
Yeah, it's about 30 years old, and you can see once it starts developing leaks like this, it's time to replace it.
Okay, so we'll replace it tomorrow. What do we do today?
Well, today we need to make a temporary repair, and for that we're going to go ahead and use this full circle repair clamp.
All right.
This is a great little clamp to use for that because it has a rubber insert that will encircle the whole pipe. It'll cover the whole thing.
Great.
That will seal the leak up really well. Now, the first thing you need to do, of course, is scrape the pipe as I was doing. Get it as smooth as possible. And this old galvanized is not too easy. Then you take the insert and you make sure that you stick it right over the top of that leak. Now you want the circle to just be right in the middle of that leak.
Okay. Makes sense.
Exactly, that way
Tightest part.
it'll stop the water from leaking off the sides.
Okay.
Then of course you'd want to come in over the top of that with your outer sleeve. The outer sleeve, it's also very important to make sure that it is centered on top of that
Okay.
leak. and you would.
So center sleeve over top of center sleeve, metal to metal like that. Okay.
Exactly. Of course, you'd hook it up on the back end here,
Right.
and you would tighten down with a wrench until the leak is stopped.
Should do it. That's also a permanent clamp, right? We could use it for that?
You could use it for a permanent repair. On this particular pipe, I wouldn't.
Okay. Yeah, I still think we need to replace that, but like we said, we'll do it tomorrow.
Definitely.
Chris, looks like a compression fitting you were talking about earlier.
Yes, this is a copper tubing size compression by compression fitting. Use 2 hook copper tubing size materials together.
Okay, comes in different sizes?
Comes in different sizes. The thing to remember is it is used for copper tubing size pipe,
Okay.
not iron pipe sized.
All right.
So I've broken one down over here, and it comes in about 5 parts. You got a barrel, you got 2 end nuts,
Okay.
and 2 rubber gaskets.
Okay.
Now, I've already put one together over here,
All right.
and we'll show you how to put the other end nut on.
All right.
First thing you want to do is make sure you have the end of that pipe as round as possible.
It gets a little bent easily.
It does, and you'd take your channel locks and kind of work it around until you can get it as round as possible.
Okay.
Okay, and you would take your end nut and slip it onto the pipe. Now, as long as you can get around there, you'll get a good seal.
Okay, that's the key.
And you would take the gasket and insert it into the operating nut.
Okay, so far.
Make sure you have that yellow spring facing the outside,
Okay.
so it will butt up against the barrel. And you would take it and tighten the end nut onto the barrel.
Great.
And you do the same on the other side. Tighten the two together, and it would connect the 2 pieces of pipe together and, form a solid bond.
That's a pretty permanent fixture.
Yes, it is.
Okay.
Yes, it
Now,
is.
what if we have 2 pieces of pipe, different types?
Different types, as in basically like if you had a piece of PVC pipe and a metal pipe, you would need a bolted flex.
Okay.
Same idea. It's a coupling, flex coupling, but it has 2 bolts that run down the side of it, and this is iron pipe sized.
Okay. So, by the way, this could occur, maybe you have an older system hooked up to a new system, something along that line you guys run into.
Exactly. Say you're hooking up PVC to a piece of galvanized
Okay.
pipe. You can't glue it, so you'll need one of these bolted flexes.
Okay. How's that work?
It's very simple. You just remove the 2 bolts, and you pull it apart here for you. You have a barrel
Okay.
in the middle. Same thing.
Same
2
kind of
ends.
setup.
2 ends and 2 rubbers.
Okay.
Okay. So we'll want to go ahead and slip that end onto the metal pipe and slip the rubber right onto the metal pipe as well. And get it down there about halfway. That's another thing that's important, is to make sure that when you are putting this together, that you have your pipe halfway
Okay.
into the
So
barrel.
you get both pipes in as far as you can get them.
Exactly, you want to
All
butt
right.
them up against each other. So we'd go back over here on the other side and insert the rubber onto the PVC. You take your barrel, stick it onto the end, and you take your metal pipe, butt it up against each other.
Okay, you can feel that.
Exactly, make sure it's nice and snug, and of course you would bolt it all back up together.
Okay, so while you're doing that, I might mention, it was practice for my guys to always disinfect in the field. You guys follow the same kind of practice with?
Yes, when we're making a repair like this, we will want to go ahead and either swab the pipe or spray it with some sodium hypochlorite.
Okay, good.
Basic, Clorox.
sure. So, all right, that looks good. This is also a permanent fitting?
This is a permanent fitting as well. Yes.
Okay. I know we want to do some work with PVC and watch it glue a little bit, so why don't we do that next?
All right.
Okay, we got our safety glasses on and see we got our chemicals out, so it must be time to glue.
Yes, it is. Like you mentioned, we have our safety glasses and our gloves. We wouldn't want to get any primer in our eyes or on our skin,
Yeah.
so that's why we're wearing them.
Okay.
And today, right now, we're about to join 2 pieces of PVC pipe together. And we're going to be using a PVC coupling. It's a slip-by-slip coupling. There's no threads inside.
Okay.
And we'll be gluing that together. So,
Pretty common activity.
it's very common, and a typical homeowner will be doing this on their own. So What you really want to do is make sure you disinfect all the couplings that you have.
Okay, I just got some sodium hypochlorite on there.
On a
You
rag.
can smell that.
Exactly, and so I'm going to disinfect that coupling, and I'll make sure that, of course, this will be in the ground, it won't be mobile, so I'd usually come in here or try and spray some sodium hypochlorite.
You can use a spritzer to spray.
Exactly.
Okay.
All right, now we've disinfected, we're ready to go ahead and prep the pipe.
All right.
We would cut the edge of the PVC, and after cutting it, you would make sure you come in with a rag and get all the burrs off the edge of that PVC pipe. Very important. You don't want anything to interfere with the glue. Okay. So we've taken the burrs off the edge of that. Now we're pretty much ready to start using our chemicals.
Okay, first
off, we want to use some primer. Now this will go ahead and this will start softening the PVC.
Yeah, the primer actually kind of turns that plastic into almost like a jelly right at the surface. I know that. It softens it up.
Yes, it will soften the edge of it. You want to make sure you apply that all around the inside of that coupling. And one important thing, you don't want it to puddle. Now this is messy, it will go all the way around, but just make sure it doesn't puddle up inside there. Okay, and you want to do the same on your pipe.
Around the outside.
Right around the outside of it there. Now we got to work fairly quickly with this. All right,
Okay.
So now we need to apply our glue.
Move that away.
The glue is applied the same way. You want to make sure you have complete coverage inside that coupling and make sure that there's no dirt or debris built up in there.
Could be a little bit of a challenge out in the field, but it's
Yes,
worth
it
the
can.
extra minute or two to get that done right.
Definitely, it'll keep you from blowing off a coupling and
Yeah,
having to do it
coming
again a
back
second
to it
time.
again.
So we'll go ahead and take that coupling, stick it onto the pipe.
All right.
Now it's very important that once you've done that, you've twisted that pipe around there
twist.
to make sure you get a good seal.
Yep.
Okay?
Okay,
as
that
you can
plastic
see-
should be hardening up with the oxygen in the air and it'll all become one.
Definitely. Now we'll go ahead and get the other side done here real quick.
All right.
So we will go ahead and same thing with our coupling. Come in here, make sure we got an even coat inside there, no puddling. And we will do the same on our pipe. And it does not take long for this to start setting up. And back with the glue again.
Chris, this same process regardless of the size of pipe?
Yes, it is. The one thing that they do recommend, though, is on 2 inch and above, you definitely use primer. Now, you
Okay.
don't have to use a primer on 2 inches and below, but it is a good idea.
Yeah, especially if you're working in maybe some high pressure areas, that would be.
It'd be good just to make sure you get the right bond.
Yeah.
Now that we've done the connection, we'll go ahead and clean off any excess here,
Okay.
just to make it a clean fit. And we should have a permanent bond.
Okay. Last thing, you do a little swab maybe?
Last
Put
thing you would want to make sure that you get it cleaned off, and you want to make sure that you flush out the line.
All right.
And maybe just cleaning the edges off there a little too.
All right.
But it's important to go ahead and flush the customer's line. That way they won't get any taste or odors from the glue.
Good point. And then we're really back in business.
That's it.
Okay. Very straightforward. Thank you very much.
Well, thank you.
Just a note, pipe materials other than PVC will require different methods of repair or replacement. Now, our final section is about preventing contamination. Any actual or potential connection between drinking water and an unapproved water source is called a cross-connection and should be avoided. Multi-story buildings, industrial sites, irrigation systems, solar hot water systems, and above-ground swimming pools are potential common sources of cross-connection with treated water. All such connections should be controlled. Cross connections have consistently caused more waterborne disease in the United States than any other known factor. Now let's join Mike and Chris Mayer again as they discuss some common types of cross-connection control devices.
Chris, you want to talk a couple minutes about cross connections. What is a cross connection?
Well, Mike, a cross connection is either an actual or potential connection between the drinking water supply and an unapproved source.
Okay. You have a cross connection control program here with the district?
Oh yeah.
And what are some of the elements of that?
Well, some of the elements of our program is to knowing where all our devices are. We have to know the location of every backflow.
All right.
We also approve installation of devices,
Okay.
and we also monitor the annual testing of our devices.
Okay, so 3 real critical elements there.
Absolutely.
Okay. There's many different devices. I think the 4 most common ones. First is an air gap. And what is an air gap?
The best way I can describe an air gap would be like an elevated storage tower and a water truck.
Okay.
You know, they pull up underneath and get filled up. It's a physical separation between the tank and the receiving vessel itself.
Okay. How about a vacuum breaker? Atmospheric pressure?
Yeah, atmospheric vacuum breakers, you'll see those mainly on residential irrigation, and we don't approve those, but pressure vacuum breakers, you'll see those on also residential irrigation and even median strips. Those are allowed there.
Okay, we have a couple more here we want to take a closer look at. This first device looks like a double check assembly.
It's a double check, it's DCDA.
Kind of walk us through here what we're looking at.
Sure. This is double check valve assembly. It has 2 shutoffs, this being the number 1 and number 2 shutoff. 2 check valves. It has 1, 2, 3, 4 test cocks.
Okay.
And you have a smaller version of that here.
Yeah, I noticed that.
Here's the double check valve, but also it incorporates a meter. And the meter is there to ensure that the fire system, this is for fire protection.
Okay.
It ensures that the fire system is using the water only in the event of a fire.
Oh, so if that's registering water use, there may be a leak.
Maybe a leak or some sort of legal connection.
Okay, that's a nice add-on. I noticed these little red boxes here.
These red boxes are alarms. And out of this alarm here, there's a shaft that touches the notch on this shaft here. When this shaft is turned, it kicks out that other shaft on the alarm and notifies the alarm company, and either the sheriff or the fire department will come out here and see what's going on.
So nice for vandal control and
Absolutely.
security.
You bet.
That's a good
It ensures
add-on.
that the fire protection's
Okay.
always there.
Now this is a large and impressive unit,
Right.
but right down here I think is the king of backflow devices.
It's the
Let's look
RP,
at
it's the
that.
king of all devices.
So reduced pressure.
Reduced pressure, that's right. It also has 2 check valves, but between the 2 it has a relief valve.
Okay.
And in the event of back pressure or back siphonage, if the number 2 check valve fails, the number 1 check valve holds, the relief valve will dump all that water to atmosphere.
Oh, so failure through a check leads to just drop to the ground.
That's right, and not back into our system.
Okay, and this is really the ultimate device to.
This is
keep
more of a
anything
mid-range level protection. This is the gives you the highest level of protection. It again has 2 shutoffs, 4 test cocks, and is required to be tested annually.
Okay. Now I know we're just like scratching the surface here, obviously.
Oh, yeah.
You have training. How much training is involved for your position?
I'm a cross-connection control specialist. I'm a certified backflow tester. I've gone to numerous courses regarding backflow.
Okay. Takes a couple of weeks?
Each course is about a week,
Okay.
but I've had many smaller courses in between.
Sure. Okay, so lots of training and
Lots of
lots
training.
of continuing education
Absolutely.
also. Okay. Guess I'll summarize. I know cross-connection control is very important. My travels around the country, I've seen some pretty wild cross connections where they shouldn't be.
Right.
And seeing that makes me more appreciative of actually having
you
a
bet.
program. So, listen, we want to thank you very much for all your time today.
You bet, no problem.
I notice it looks like it's going to rain.
It looks like it's going to rain,
and
don't it?
I think we'll just get out of here.
Let's get.
All right.
Okay, Mike, thanks.
Today we talked about the basic parts, components, and procedures used in water distribution fieldwork. Like most successful coaches will tell you, you've got to be able to do the basics very, very well. I know that all the jobs are going to be different. Small leaks, large leaks, hot weather, cold weather, rain. Be willing to adapt and be patient. When you get out on a job site, the first thing you should do is assess it carefully. Look at safety hazards, trenching, shoring, electrical issues, possible gas lines. Don't jump into a job until you have a plan. Also, make sure you have assistance. Don't do jobs by yourself. Notification. If you're working on someone's property, let them know that you're there. Always let your supervisor know where you are. While you're doing the job and afterwards, make sure that you disinfect your parts with sodium hypochlorite. When you're done the job, flush your lines, make sure that it holds up under the pressure of the system. Finally, document your efforts, complete your work orders, and make notes that can help you in the future. Do all these tips and you'll work safely and effectively in the field.
You've just seen some of the procedures and types of equipment used in water distribution systems, and some of the basic techniques and procedures for maintaining their integrity. Supplying the maximum continuous and safe water supply at adequate pressure and at the lowest reasonable cost is the primary goal of every water system. A solid, well-implemented, ongoing program of regular testing, preventive maintenance, and efficient emergency and repair services is the primary tool for meeting that goal. We looked at a number of types of system valves used for a variety of applications. Do your research and make sure you choose the right valve for the job when replacing or installing a new valve. Valves should be inspected and exercised at least annually. To exercise a valve, simply close and open the valve a few times. This helps to clean out mineral deposits or other debris, such as rust, which helps prevent valves from sticking and the stem from breaking. Also, when the valve is closed, listen carefully to be sure the valve has actually stopped the flow of water. You can do this by placing your ear to the handle of the valve stem or another object that is in contact with the valve. If it hasn't closed completely, schedule maintenance or replace the valve as necessary. Close and reopen valves slowly. A sudden change in downline water pressure can result in water hammer, which can cause significant damage to joints and fittings all along the line. After reopening the valve, if you hear a repetitive banging or pounding noise, this is an indication of water hammer, which can cause damage also. Here are some tips. Don't over-tighten valves. For example, in a butterfly valve, you can break the worm-style gears. Back off a partial turn when the valve is fully open to prevent the valve from locking or freezing. When appropriate, use insulated valves. This avoids electrolysis in the metallic pipes and increases the life of the pipe. A good valve exercise program is of little value if you can't find the valves to begin with. Accurate maps are vital for locating valves and for the efficient maintenance of a water system. If changes are made in the system, make sure maps are updated, record the type of valve and the number of turns from open to closed on the distributions map. Some distribution systems need flushing more often than others. Keep good records of complaints of turbidity, odor, and taste. This will help you to design a flushing program and schedule that matches the requirements of the system. All flushing should be done safely. Water should be directed away from pedestrians, private property, underground utility vaults, and vehicle traffic. If you disinfect your system, you may need to take special precautions to direct flushed water away from storm drains that flow to creeks, streams, or other waterways. The water may need to be dechlorinated and may require a discharge permit from the Regional Water Quality Control Board. Installed and repaired valves and pipes must be disinfected and properly flushed before being put into service. Make sure you have a good leak detection program in place. Consider investing in specialized equipment, or you may decide to hire a professional leak detection service. Either way, detecting leaks accurately and in a timely manner can save a lot of money and prevent potentially catastrophic damage, such as earth movement, when leaks wash away supporting soils. The same goes for locating buried pipes. Investing in a simple transmitter and receiver will save time and money. When repairing a pipe with a coupling, make sure you measure the pipe accurately and choose the correct coupling for the job. You do not want to be called out again for the same repair a few hours or days later. When gluing PVC pipe or when cutting pipe, wear safety glasses and gloves. For all repairs, disinfect pipe with a sodium hypochlorite swab, bleach spray, or tablets. Most distribution systems will have a variety of cross-connection control devices. Make sure you have a cross-connection control program. Know where the devices are and maintain an inventory. Approve installation of any device and monitor regular inspection and annual testing, and note in your inventory. Make sure that you keep clear records of all pipe and valve inspections, tests, maintenance, and repairs. Collectively, these records are the history of the system, where problems recur and what maintenance and repair solutions work and which ones don't. keep these records for at least 10 years. Completing this section on water distribution systems, we want to thank Mike Cherniak and his guests Scott Bear and Chris Nelson with the Carmichael Water District, and Chris Mayer with the San Juan Water District for their contributions to this program. A list of all the video programs available in this series will follow. I'm Dave Bender. Thanks for watching.